got an initial silt deposit onto which the mound is built. Slope wash, slope wash, slope wash, silt. Nice transition onto a normal ancient soil profile. This is natural levee soils. This soil is, this black stuff, this dirt, is derived from this gray stuff through the addition of organic matter through time, etc., etc., etc. So what we've got is a normal ancient topsoil onto which there's this light silt. And on top of that, there's slope wash. So the $10,000 question is this silt here in place, or is it just the first massive slope wash event, or not? So I'm going to take these back to the lab and try to figure that out.
What do you do when you go to the lab? Are you cooking? Are you baking this stuff for water content?
Well, what we will do is air dry them first, because you want to have the soils have the same. You want to have all your samples have the same water content. So ideally, what we will do is stick them in an oven. Any samples we're interested in, and dry it at 200 degrees for 24 hours.
Yeah.
Drive all the water off of it. Then we can compare the soils at a constant level of moisture.
Right.
Most of what we do is some kind of processing that involves changing the weight by removing certain elements or certain. So what we need to do is know what the weight of the soil is at a constant moisture, so then we can compare all of the results afterwards.
Right.
So that's what we're, I'll take them back to the lab and do descriptions on them, and then from there I will do what we call loss on ignition, where we burn all the carbon out of the sample, put it in an oven for an hour at 550 Celsius, which is like 1200 degrees.
Yeah.
Then we weigh it, and that's all the organic carbon burns out by 550 at an hour. Then we'll stick that same sample in 950 Celsius, which is hotter than the sun, I think. I get sunburned standing next to the oven. So then we do that, and that'll burn out all of the carbon. So between the organic carbon and the total carbon, that's what we call our inorganic carbonates. So we can get a sense of where the soil is coming from and possible post-depositional enhancement of organic carbons.
Okay.
So if people are dirty, they drag carbon around with them in the form of, if you're wearing deer skin, and it's going to start shedding. You shed skin cells. Well, the basis of that's carbon. There you go.
Yeah.
And then I look at phosphates. Similar idea. People are dirty. As they drag in and enrich the carbon content of soil, bacteria break this carbon down to form soil phosphates, because the building blocks of any kind of cell is phosphate compounds. What is it? Or a couple of different very important phosphates. I don't remember. I've been out in the sun a while.
Yeah.
But there's quite a few that are important, and every cell has them. Every living cell has them. And so if you have deer skin, if you're eating, if you're just enriching the carbon content of soil from living on it, those kinds of things, cause a spike in the phosphates. So I can tell people who lived on a soil by looking at the phosphates.
Right.
Which is very important to know, because there's a lot of soils in that mound that look like they've been lived on, but I can't tell you just by looking at it.
Yeah.
So
Okay.